Hello friends, welcome to this video on the topic Performance Factors Analysis. I am Shomir Roy, Professor of Computer Science and Engineering at National Institute of Technical Teachers Training and Research, Kolkata. There are two videos on the topic Performance Factors Analysis, of which this is the second part. In this video, we will discuss the subtopics relationship mining, correlation mining and students interaction network analysis. After successful completion of these two videos, you will be able to explain various educational data mining concepts and techniques such as latent knowledge estimation, Bayesian knowledge tracing, performance factors analysis, relationship mining, correlation mining, students interaction network analysis, etc. and take initiative to apply the aforementioned EDM techniques to technical education in our country. Let us start with relationship mining. Relationship mining is a process of finding or predicting hidden relationships among the users of social networks. Nowadays, there are numerous applications of relationship mining such as market analysis, business intelligence, personal profiling, discovery of community structures, email filtering, finding social relationships, mining positive negative relationships, fixing trust network or voting network and so on so forth. However, relationship mining in large networks has several challenges. For instance, certain personal data may remain hidden in the network. Another problem is while communicating, people generally use unstructured or semi-structured language. The question is whether we can find relations automatically in spite of incomplete user information in online social networks. There are several efficient systems for relationship mining such as Flink, Polyphonate, BCPDM, etc. There are several efficient systems for relationship mining. Flink is based on semantic web technology for the purpose of extraction and analysis of online social networks. Polyphonate is a social network extraction system capable of extracting interpersonal relationships, detection of social groups, discovering keywords for a person, and BCPDM is cloud computing based data mining system that is used for text mining and social network analysis. Ample research works have been conducted on discovering relationship in social networks. Some of these have considered structured data to obtain relationships based on syntax. Some have taken two-step approach combining syntax based with semantic based mining of relationship. The concept of relationship mining have been generalized for structured and unstructured text documents in social network domains. Suitable features from individual documents are collected and stored in a graph. Then a reduced node social graph with relationships is generated from this graph. This approach has been found to be effective for various social media documents irrespective of text document type and social network domains. Relationship associations are forms of knowledge generation on the basis of binary relationships among entities in semantic graphs. A relationship association consists of two binary relationships with a shared entity which co-occur frequently in the semantic graphs. Such connected relationships are considered as generalized knowledge mined from the collection of knowledge resources. Correlation mining. Correlation mining is concerned about identifying underlying dependencies among objects. Of late, data mining techniques are widely being applied to many non-traditional domains where traditional approach to discover knowledge from huge data do not help. Existing methods are unable to model the requirements of such large volume of data. This is why correlation measures are used for extracting useful knowledge from voluminous, spurious patterns. Correlation mining is useful to study the relationship between learner attitude and help-seeking behavior. The goal of correlation mining is to discover linear correlations, either positive or negative, between variables. Different measures are used to find correlations. Correlation mining in graph databases primarily focus on searching structural similarities. However, it is interesting to note that structurally dissimilar graphs may appear together within the database, such as the chemical isomers. Two popular correlation measures are one lift, two chi-square. Lift is defined as lift AB is equal to probability of A union B divided by probability of A multiplied by probability of B, and chi-square is equal to summation over OI minus EI whole square divided by EI, summing over all i's. If lift AB is greater than 1, then A and B are positively correlated. If lift AB is less than 1, then A, B are negatively correlated, and if lift AB is equal to 1, then A and B are not correlated. That is, they are independent of each other. The adjacent figure illustrates the idea of positive and negative correlations graphically. For the source of this figure, please see the E content. The measure chi-square is an expression for the relationship between two categorical variables. The chi-square is a value that reveals the difference between the observed counts and the expected counts in absence of any relationships in a population. Finally, we come to students' interaction network analysis. Usage of internet is increasing in leaps and bounds. Social networks have become extremely popular as a platform for communication and interaction outside the classrooms. In fact, the social media is fast producing the next generation of innovative social learning. It is difficult to establish support and contact between students and teachers in distance learning. So, we need to establish a network between the learners as well as between the learners and the learning contents, which facilitates appreciation of the feelings and emotions. Thus, teachers and tutors need to observe and support the students participating in discursive interactions so that the spirit of mutual trust and collaboration among the learners of a course is maintained. Valuable information about the learner's learning process can be extracted from their interactions on online discussion forums. Most of this information is available in the contents of posts. However, in order to discover the hidden knowledge, we need to analyze the social interaction patterns among the participants of discussion or the stakeholders, that is the students and the teachers. Applying social network analysis metrics on academic data, we may develop deeper insight on students' behavior pattern. On the basis of the type of discussion learners have online discussions on forum, it is possible to predict the grades of a learner in a course. A social network can be mathematically modeled as a directed graph. It is possible to analyze the similarities or differences in interactive models of a social network represented as a directed graph by defining the network as weighted. Hence, students' interaction network can be used to measure collaboration. Moreover, the exchanged messages are mined to understand the student conversation for pedagogical purpose. This figure shows the basic framework of educational network analysis. For the source of this figure, please see the e-content. Interesting patterns are revealed through analysis of students' interaction networks. This figure shows how, with time, the participation in the discussion increased and the network becomes more and more inclusive. It is evident that as the course progressed, number of posts by students also increased. Again, for the source of this figure, please see the e-contents. So, my friends, this completes the lesson on the topic performance factors analysis. I hope you have found the learning experience rewarding and enjoyable. For further details as well as some case studies, please see the e-contents on the whole lesson. Thank you very much and see you again. Have a good day.